Hey everyone. Sorry I couldn't be there with you today. But as you'll see for the first time today, when I can't be with my class, I tend to record a video that you can follow along with for the entire class period. And so that means that the expectation is that you're learning just as much in my class on a day that I'm not there with you as you would on a day that I am actually there with you. The way this will work today is that we'll be going through this packet together that you picked up on your way in the room. I will go over some parts of it, and then I will give you some time to work with people near you. I'll set this timer so you can always see how much work time you have. But then since I'm not actually in the room to be able to, sort of help you out when you're working, I need you to really rely on each other. If you know that someone near you really knows what they're doing and you need some help, work with them. And if you know that somebody near you kind of needs some help and you know what you're doing, help them out. You should be working with the people near you, maybe like next to you on either side, maybe directly in front of you or directly behind you is okay. But I shouldn't have people up running around the room, going wanting to sit with their friends on the other side of the room or any of that stuff. And then when it's time for me to talk, this timer will be going off. It's really important that you stop what you're doing, face the front, quiet down, and get ready to listen to my part of the lesson, because I'm not there to know that people are talking, so I can't wait for that. I can't like speak louder to talk over people who are talking. I can't repeat myself. I mean, I suppose whoever's there with you could replay the video, but everything's sort of timed to where that wouldn't work out very well, actually. So let's get to it. Today's goal is to continue our look at graphing proportional relationships, but more importantly, we're looking ahead to like a further goal, which is to be able to look at the various forms that we represent proportional relationships with, mainly being tables, graphs, and equations, and being able to move swiftly between them. If you see an equation, you should be able to build a table from it. And if you see a table, you should be able to make a graph from it. And if you see a graph, you should be able to turn that into an equation. We want to be able to be flexible in our movement between all of these representations of these proportional relationships we've been working with. So on page 1 here of this packet, it says grandma's special chocolate chip cookie recipe, which yields 4 dozen cookies, calls for 3 cups of flour. Okay, so we've got a 3 cup, that's not the best pen, and I'm off the screen. Hold on, let me get together here. There we go. So I started to use a screen pen, but not very good. So we have this like 3 to 4 ratio here, this being flour and this being cookies. And we do keep in mind that that's 4 dozen, so really it's 48. But if we kind of keep in mind the idea that it's dozens the whole way, we should be able to work with this 3 to 4 ratio. So let's create a chart comparing the amount of flour used to the amount of cookies. Okay, when they say a chart, I would assume they mean a table. I usually call it a table, so let's just make that. So let's put flour over here, and let's indicate that it's cups. And let's put cookies over here. Let's indicate that it is dozens, D-O-Z. So since I put flour on the left and cookies on the right, that sort of says that I'm intending to treat flour as my X sort of value here and cookies as my Y value. And so all we know is that 3 cups of flour makes 4 dozen cookies. But we can create more values from that, right? We expect that a recipe should stay proportional. If we want the cookies to come out the same every time, we have to maintain the same ratio of flour to cookies. We can't start adding more flour. They're going to turn out all dry, probably, I would imagine. I don't know. I'm not a baker. You put less flour, they turn out probably gooey, I would imagine. I don't know. So if we were to use 6 cups of flour, we'd essentially be scaling the recipe by 2. And so we would want to double, we would get double the cookies and have 8. And then we could sort of make like a triple batch, right? If we were to triple this 3 here and make 9, we could triple this 4 and make 12. And I think that's good enough. We don't have to make a table with like a million different values. So it says, is the number of cookies proportional to the amount of flour used? Explain. Well, we know it's proportional because we sort of built it in a proportional way, right? We built it so that the ratios along the column stay the same. But you know what? Let's go ahead and find a unit rate anyways, so that we can use it later. That information always comes in handy when we want to make graphs and equations. So if we were to make a third column on this table and we called it, well, let's have this be F and this be C. We could have oops, I almost messed that up, the C divided by F column. And you may have calculators at your desk or not. If you don't, maybe during your first work time, you could grab one, but not right now. 4 divided by 3, you could just write that as the fraction 4/3. But how about we go with 1 point? No, actually, I don't want to do that. I don't want to write this as a decimal because a decimal would do 1.3 repeating, and that gets really ugly. So we are going to use the fraction 4/3. So for every cup of flour, she gets 4/3 of a dozen of cookies. 4/3 of a dozen. So you got to think in your head, what is a third of a dozen? That should be 4. And you're getting 4 of those thirds. So she's getting 16 cookies for every cup of flour. But we're going to call it 4/3 of a dozen. 4/3, all right, 8/6 also simplifies to 4/3, and 12/9 also simplifies to 4/3. So yes, it is proportional. And K equals 4/3. And so now we're asked to find the unit rate, which means like how many cookies do you get for every 1 cup of flour? Well, we already did that. That's exactly what this number is. The constant of proportionality and the unit rate, how much you get of your Y value for 1 unit of your X value, they're the same thing. So 4/3 is the unit rate. And it asks, what does it mean in the context of this problem? That's its way of asking you to just explain what that 4/3 means in terms of like cookies and flour, right? Like you have to relate that number back to what the problem's about, cookies and flour. And what this 4/3 tells us is that for every 1 cup flour, she gets 4/3 of a dozen, which is a weird way of thinking of things. It means 16 cookies. All right, so now let's take this information and turn it into a graph. So when we were working on graphing the other day, I said I always want your graph to either have a title or a legend. I should have also said that it's okay if you just label the axes, as long as there's information on there telling people what it is. So our X value in the X side of our table here is the flour, cups of flour. So let's put cups of flour along the X axis. Make sure you leave yourself enough room to label some of these boxes. We're going to do some scaling. And then the Y axis should be cookies. And we should indicate that we're talking about dozens. All right, and so it looks like the biggest number we really need to get to is 12. And we've got more than 12 boxes on the X and the Y axis. So let's just scale by 1. But we don't necessarily have to mark every single box. That gets ugly if you do that. Let's just mark 5, 10, 15, and then we can count the boxes in between when we need to do stuff. So this is weird here though. Be careful with this little notch they made here, because they made a notch at like 2, but then 5 up from there, 5 up, that's weird. So it's like this notch is at 7. So okay, I guess we can call this notch, if we want to use the notches, that can be 2, 7, and 12. I guess that's convenient for us because we need to be able to find 12. I don't know why they did it that way though. Okay, so let's graph these points here. For 3 cups of flour, she gets 4 dozen cookies. So we go 3 on the x-axis, 1, 2, 3, and then up 4, 1, 2, 3, 4. Okay, so there's my 3 comma 4. I'm not gonna label it or anything like that because it just makes graph messier than it needs to be. The next one is 6 comma 8. So I'll go to 6, which is just past 5. And then I count up 8. Well, I know this one right here is 7. So there's 8. And then the last one I'm going to do is 9 comma 12. So 9 should be just before 10. And then I'm going to go all the way up to 12, which luckily is labeled for us. So there we go. Now, when I connect this line, I'm thinking about a cookie recipe, right? If I wanted to, I could make even bigger recipes. I could make the 12 cups of flour, 15 dozen batch, and I could make the more and more and more. I could make 1,000,000 cups of flour batch if I wanted to. I could also make no cookies. I could take 0 flour and make 0 cookies if I felt lazy one day. And so because of that, that's why we connect this line and we let it go off in both directions all the way, because this line represents more than just this table does. It represents all the possible recipes we could choose to do. The next question says, does the graph show the quantities being proportional to each other? Absolutely, because it has the 2 characteristics we look for, and that's the line is straight and it contains the origin. So yes, the line is straight and contains the origin. Okay, and so the last thing we need is an equation that can be used to represent this relationship. You should look up on the wall right above where I normally teach from in our classroom, and you will see the general form of the equation. It says y equals kx. But remember, we have to kind of switch the letters here because I chose to use F for flour, but it's going to go where x goes in the equation, right? Because it's sort of like our x values in the table. And we're going to use C for cookies. And since it's in the y position, we'll replace it with y. So we're going to go C instead of y. And then for k, we never put the letter k in our equations. We always put our actual k, which was this 4/3 that we've written in all different places. So C equals 4/3 F. The number of cookies you can get in dozens equals 4/3 times however much cups of flour you use. Okay, what I'd like you to do is work with the people near you on the next page of this one about the chocolate chip cookies, right? I think this whole thing's about cookies, different kinds of cookies or whatever. So you try to do this whole page with the people around you. There's only 3 questions to go with it. So let's do 2 minutes per question. You got 6 minutes to work, and then it's my turn. All right, I'm going to be looking for your attention back in 5, 4, 3, 2, 1. Just waiting a moment. So hopefully people are quieting down, turning toward the screen, ready to go. So hopefully you got some good work done on this page in that 6 minutes. I should have said before, if you get done with the part that I'm asking you to do in 6 minutes, you could go to the very back page where it has the problem set for like a little bit of extra challenge, or even more preferably, you could check the people around you to see if they're understanding things as well as you are. So here it says, below is a graph modeling the amount of sugar required to make grandma's chocolate chip cookies. Question A says, record the coordinates of flour of the points from the graph in the table. You know what? I feel like it means to say 4. You know what? I wish I would have read that ahead and told you before I gave you 6 minutes to work. I'm pretty sure it means 4, not flour, because there's not even flour going on here. We got sugar and cookies. So I don't know. Hopefully you picked some points and just wrote down the coordinates from them. When we do this, the best thing to do is to look for coordinate points that cross grid lines nicely so that you can tell that they're supposed to be exactly like on that point, on that whole number coordinate number. It's hard to say what I mean to say. If it's crossing through, like between 2 intersection points, then you can't really tell if it's supposed to be 3.5, 3.6, 3.7, who knows? So I look for the ones that cross nicely on the intersection points. And I think they've got them sort of like marked for us here. So, right, like it told us to do 4 points and then it has 4 of these marked off. So I'm pretty sure this is a typo. If you're the person who's teaching my class today, you're probably seeing this part for the first time in first period. If you could warn 4th, 5th, and 6th period about that flour typo, that'd be great. So let's see here. It looks like this point here is 2 and then up 3. So we've got a point at 2, 3. Oh, that marker's dead. You gotta get a different one. And then this point appears to be 4 on the x-axis and 6 on the y-axis. So 4, 6, which makes sense. I see a pattern here, right? The 2 doubled to 4, 3 doubled to 6. That's the sort of pattern we expect to see in a proportional relationship. Let's see here. So next we have, this looks like 8 on the x-axis and 12 on the y-axis, which is something we also expect to see, right? The 4 doubled to 8, the 6 doubled to 12. Good pattern so far. And lastly, it looks like we have 12, 18, right? Yep. It says, what do these ordered pairs represent? So this is just checking your ability to read a graph. The first number represents number of cups of sugar you need. And the second number represents how many dozens of cookies you get. So we can just write cups of sugar and dozens of cookies. So the next part says, Grandma has 1 remaining cup of sugar. How many dozens of cookies will she be able to make? Plot the point on the graph above. Okay, so this is going to be a really important point that we're going to graph, and it's going to get a special name, and we're going to talk about it a lot. So the first thing we have to do is figure out how many cups of sugar she can make with how many dozens of cookies she can make with 1 cup of sugar, AKA the unit rate, right? How much of something you can get per 1 of the other thing, that's the unit rate. But the unit rate and the constant of proportionality are the exact same thing. And we know that we always get a constant of proportionality by doing one of our y values. I mean, I guess maybe this is C value because it's cookies or whatever, but we know that this is the y position and this is the x position. We do a y divided by an x, we get our k, and the k and the unit rate are the same thing. So let's just do 6 divided by 4. I could have chosen the y and the x from any of these points. I just randomly chose the 6 and the 4. I know that as a decimal, that's 1.5, so we can use 1.5. And so what this tells us is that she gets 1.5 dozens of cookies for every 1 cup of sugar she uses. And we're supposed to plot this on the graph. So what we do is we go to 1 on the x-axis or the sugar axis, whatever you want to call it in this case. And then we find 1.5, which would be right between the 1 and the 2. It's going to be right here on the graph. And so specifically, this point is 1, 1.5. That's what this point is. But in general, it has 2 names that we have to be used to. This point is called the 1, r point, because the x value is always 1, and the r value there, or the y value, is always the unit rate, right? Because you're plotting, oh, if I have 1 of whatever this value is, this is how much of the other value I get, aka the unit rate. So they call it the 1, r point, because the second number is your unit rate. It is also sometimes called the 1, k point, for the exact same reason, except k is the constant of proportionality. And you can look at a graph and go to 1 on the x-axis, look up to see where the line is, and whatever your y value there is your constant of proportionality. On some graphs, that's a really useful trick, because you can literally just look at it and say, oh, the k is 3, because I can tell that the point 1, 3 is on this graph. But some other graphs, you can't do it so easily. Like on this one, it would have been hard to tell that was exactly 1.5 without us doing some math first. So sometimes it's a useful thing. Sometimes it's a thing that you're asked to find. But either way, it's a really important point. And the last question down here says, how many dozens of cookies can grandma make if she has no sugar? Can you graph this point on the grid provided above? What do we call this point? So no sugar obviously equals no cookies. And that would be the point 0, 0 on the graph. And we call that the origin. And of course we can graph that. It has to be on there because it's a proportional relationship, and it's right here. All right, so we're gonna essentially keep doing the same cycle. I want you to go on and try your best to do the next question, which is about how many gallons of water you have and how long you can shower with that amount of water. And this time, since there's a few more questions, let's go for 8 minutes of work time. Remember, you can work with the people near you, help each other. If you get done before the 8 minutes, check like the problem set in the back for like a little extra challenge. There's challenge work on the wall you could do in there, or the best thing you could do is check around the people near you, see if any of them need help. Okay, let's be ready in 5, 4, 3, 2, 1. And I'll wait a few more seconds for people to quiet down and be ready to listen. All right, we got a graph that shows you have this many gallons of water. This is how many minutes you can shower for. We see immediately that it is a proportional relationship because this graph has a straight line that contains the origin. And so that's actually the very first question is, can you determine by the graph that it's proportional? Yes. The line is straight and contains the origin. All right. The next one says, how long can a person shower with 15 gallons of water and with 60 gallons of water? So gallons of water is on the x-axis here. And let's look at 15. It looks like this graph is scaled with 5 gallons for every grid line on the x-axis, but 1 minute for every grid line on the y-axis. So we gotta be careful with that. So 15 should be 3 boxes over, and then we just gotta look up on the graph and see where the y value is on the line. And it looks like it's this point right here. It's 15 gallons, 5-minute shower. And so we write that as the ordered pair 15, 5. And so maybe we can put underneath that it'd be a 5-minute shower, because that's what they're asking. It's like how many minutes. So we can specify that. And then the other one is 60 gallons. We got 60 gallons. Let's see here. That's 4 times as many gallons, right? So I think the answer is going to be 20. Let's see. I'm going to go to 60 on the gallons axis, go up and find the line. Here's my point. It does indeed look like it's right at 20. So we got the point 60, 20, and we'll say a 20-minute shower. Next, it asks, what are the coordinates of point A? Describe point A in the context of this problem. That means you got to refer back to what this problem is about. It's about gallons, and it's about water. It's about how long you can take a shower for with certain numbers of gallons. So your answer has to be in words. It says something about those things, showing that you know what these points mean. So let's see here. This point is 25, 30, 10. Okay, so the coordinate of this point is 30, 10. And it means you can take a 10-minute, I almost said 30-minute. I almost got the values mixed up, and that's what this question's all about, is making sure you don't do that. 10-minute shower with 30 gallons. Okay, now it asks, can you use the graph to identify the unit rate? So you can't very easily, right? Like what we would love is if we could just go to 1 on the x-axis and look up and find the y value right there, and we would just have our 1, r or 1, k point and be done with it. But there's no way to tell where 1 even is on this x-axis and what the y value would be there. So we can use the graph to identify the unit rate. We're just going to have to do a little bit of math. We're going to have to do it the old-fashioned way by taking a y value and dividing by an x value. Or I guess we might say, if we call this G for gallons and M for minutes, then we want to do an M value divided by a G value. We might as well take these right here because these are easy, right? They're both multiples of 10. I've got a y value, aka an m value here in 10, and an x value, aka a g value right here. So we're going to do 10 divided by 30, but that simplifies down to 1/3. So the unit rate is 1/3. We should put units on it. That's minutes per gallon. You get 1/3 of a minute for every gallon of water you got. 1/3 of a minute is 20 seconds. But We don't need to have that. We can keep it as 1/3 of a minute. So the next thing says, plot the unit rate right here. Plot the unit rate on the graph. Is the point on the line of the relationship? So it's kind of hard to plot exactly this point. This point is going to be 1, 1/3. And I mean, it's somewhere like right around here. We can label it. And yeah, it's on the graph. I mean, it has to be. How can you have a proportional relationship being represented by a graph and it doesn't have a unit rate on there? That wouldn't make any sense. So we don't even have to write that. It's such a silly question. Of course it's on there. Lastly, write the equation to represent the relationship between gallons and the length of a shower. So we just need this number right here. This 1/3, that's our K, or our unit rate. We have G for gallons and M for minutes. I think I forgot to define my variables on a previous question. So if you did it without me having to do it, great job. And so our equation here is the minutes always equals 1/3 the number of gallons you have. Okay, there's only, I'm guessing, I don't have a timer telling me how long I've been doing this video, but I think there's about 5 minutes left in the class period, maybe a little bit more, maybe a little less. What I'd like you to do is try your best on this last, I guess this is the last section. So this section runs all the way through the next 2 pages, this part about the amusement park. I want you to get as far as you can on it. Don't pack up early. Don't start getting all crazy just because the period's almost over. Work on this for a couple minutes, however many minutes you have. And then in the last minute of class, please make sure your name is on these and hand them in. I'm going to give you a classwork grade for the day based on how much of this you were able to at least complete or copy. I mean, you could have just been copying along the whole time, right? Okay, so that's going to be it for me. Have a good rest of your day, and I should see you tomorrow.